Welcome guys, welcome to my channel Marine Sea Time. Today I will be discussing about the term cavitation, its effect and what are the causes of cavitation. So before going into the cavitation topic, let me discuss some points. So here you can see this is the diagram. So this is the tank of in which the liquid level is of height h, P is the atmospheric pressure, Hs is the height from the tank to the pump impeller. So now this will be negative and this will be positive Hs. This is the friction loss at the suction side and the vapor loss at the suction side. This is the friction loss at discharge and vapor loss at the discharge side. This friction and vapor loss will act in opposite direction to the flow of the fluid. So before discussing about cavitation, let us first discuss some points about NPSH. What is this NPSH, net positive suction head? So in order to understand cavitation, NPSH is required because if the NPSH, net positive suction head, is 0 or negative, the cavitation starts in the centrifugal pump. So here you can see this is all NP. So the final formula for NPSH is Pa plus H, Pa plus H minus Hs plus frictional losses plus vapor losses. So Pa is the atmospheric pressure, H is the height of the liquid in the tank, Hs is the height from the tank to the impeller of the pump. This is the frictional losses and this is the vapor losses. So these three terms are the losses in the pump. So we will subtract this from the positive. So this will act as a profit for the pump because Pa is the atmospheric pressure which is acting on the tank from above, and H is the height. So these two factor will add these two factor will give profit to the pump, and this frictional losses is not required. Vapor losses is not required. Hs, if the tank is above the pump, then Hs will be negative. So this will also add to NPSH, and if the pump is below and if the tank is below the pump, the Hs will be positive. So this will act as a loss to the pump. And if Hs is negative, if the tank is above the pump, it will be negative. So profit in this case. So this is all about NPSH. No, now if the NPSH becomes negative, that means cavitation will occur. So how it can be negative? If the vapor losses is more, if the frictional losses, in the line is more, if the height of the tank, if the pump is below the, if the tank is below the pump, and the tank height below the pump is too much, that the NPSH value will be negative. So these are the three cases. And if the height, if the liquid in the tank level is low, then also it can cause NPSH to become negative. Pa is the atmospheric pressure which is constant. So these are all the causes which can make the NPSH to go in negative value. So vapor losses, we have to reduce the vapor losses. How we can reduce the vapor losses? By decreasing the temperature of the liquid flowing into the pump. Frictional losses, reduce the frictional losses, make the tank above the pump. So install the pump below the tank level at a certain height. So this we can increase or decrease. This is in our hand. So this is all about the NPSH. This is the formula for NPSH, you can see over here. Now we will go into the topic. What is NPSH? At any point in a liquid, pressure drops below the vapor pressure of the liquid corresponding to the temperature of the liquid. Bubbles start forming, which is called cavitation. If any point in the pump, with the liquid flowing into the pump, if its pressure drops below the vapor pressure of the liquid corresponding to the temperature of the liquid, bubble starts forming, which is called cavitation. If the liquid flowing into the tank, if its pressure becomes more than the surrounding pressure of the pump, then it can cause cavitation. So in the cavitation, the vapor bubbles form and move along the vein of an impeller. So it will move along the vein of an impeller, and at the vein of the impeller, the pressure around the bubbles begin to increase. So when a point is reached where the pressure on the outside of the bubble is greater than the pressure inside the bubble collapses. The process is not an explode but rather an implode. This collapsing bubble isn't alone but is surrounded by hundreds of other bubbles collapsing at approximately the same point on each impeller vane. So suppose this is the bubble, and if the outside pressure means pump in the pump impeller we have a pressure here. So if the outside pressure is greater, if this pressure is greater than the pressure inside the bubble, if this pressure is greater, then it will collapse it. Okay. The phenomena of formation and subsequent collapsing of these vapor bubbles known as cavitation has several effects on centrifugal pump. So one by one we will be discussing about what this thing, what this cavitation can affect the centrifugal pump, in what all ways it can affect the centrifugal pump. So uh, first it will make a the first effect is that it will make a noise. Okay. And this will make a growling sound. This can be nuisance in an extreme situation where a cavitation pump is operating, where people are working. However, this physical symptoms is usually the least area of concern with cavitation. Of far greater concern is the effect of cavitation on the hydraulic performance and the mechanical integrity of the pump. So we have three effects of the cavitation on the pump. First one is the noise; it will make a noise which is not of much importance. Second one is the hydraulic effect. So what is this hydraulic effect? The hydraulic effect. See, this is the HQ diagram. You can see the diagram. So because of this cavitation, you can see there is a breakaway here. So there is a breakaway so producing a low producing a lower than expected head and flow. So the discharge so so the discharge will be less at a particular head. If the head is very small, then it was supposed to have a high discharge, but it will give a low discharge at expected head and flow. So the hydraulic so there will be a consequences in the hydraulic effect. Now the third one is the mechanical damage. This is a very important. This is the very important. An even more serious effect of cavitation is the mechanical damage that can occur due to excessive vibration in the pump. So the cavitation can bring excessive vibration in the pump. This vibration is due to the uneven loading of the impeller as the mixture of vapor and liquid passes through it, and to the local shock wave that occur as each bubble collapses. So local shock wave will be generated as the each bubble collapses. A shock wave can physically damage the impeller, causing the removal of the material from the surface of the impeller. The amount of material removed varies depending on the extent of the cavitation and the impeller material. If the impeller is made up of ferrous-based material such as ductile iron, material is removed from the impeller due to the combination of corrosion of the ferrous material from the water being pumped and the erosive effect of the cavitation shock wave. So if the material of the impeller is of ferrous-based, it will be totally eroded, firstly by the corrosion and secondly by the cavitation effect shock waves. This cavitation shock wave can damage and can remove the impeller material. Now if the impeller material is of corrosion resistant, let's suppose it is made up of bronze, then the damage will be very less. And if it is of stainless steel with superior corrosion resistance, then it has a better ability to resist the metal losses associated with the cavitation. In any case, the removal of material, if it occurs at all, proceeds as long as the pump is cavitating. Pits can gradually be formed on the impeller vanes, and in extreme, the removal of material can actually cause a hole to be eaten clear through an impeller vane. So a hole will be created into the impeller vane. So this can obviously affect the upsetting the dynamic balance of the rotating component. So any rotating component has a dynamic balance. So if any hole is made into the impeller in the vane, then it can make the impeller imbalance. So this is same as the if the car tire isn't working properly. So this is just like that. If the car tire isn't working properly, so the car will be unbalanced in that case. So this is the same case for the pump too. The excessive vibration caused by the cavitation often subsequently causes a failure of the pump seal and its bearing. So these are all the effects of the cavitation. It will make noise. Secondly, it will deteriorate the hydraulic effect. It will have a hydraulic effect. It will lose. Hydraulic effect means the efficiency of the pump will deteriorate. The pump efficiency of the pump will decrease. Third one is the mechanical damage. Mechanical damage means erosion of the making hole in the vein by the cavitation shock waves, and this can upset the dynamic balance of the rotating component. Now we will discussing about the causes of the pump cavitation. So beforehand I have told you that if the NPSH is low, then it can cause cavitation because of the fluid at the pump suction is not available sufficient above the vapor pressure of liquid at the operating condition. With the fluid flowing into the tank, if its pressure is very low, if suppose the NPSH net positive suction rate is low, that means the pump will lose suction and some amount of only water will come into the pump. So its pressure will be approx very less than the actual pressure of the pump inside. So the liquid flowing in the pump will form bubble and will cause cavitation. If suppose the increases the temperature of the pump liquid, if the temperature of the pump pumped liquid is increased, then the vapor pressure will increase. So I have told you that in NPSH formula is equal to Pa plus H minus Hs plus frictional losses plus vapor losses. So if the vapor losses is increased, then the NPSH will be decreasing and the pump will lose suction. And as the pump lose suction, there will be no liquid flowing into the pump, and the liquid flowing into the pump, if some liquid also flows into the pump, then then the liquid flowing into the pump will form bubbles and will cause cavitation in the pump. Third is the increase in the fluid velocity at the pump suction. So according to Bernoulli theorem, we know that higher liquid velocity means higher velocity and lower pressure head. So frictional pressure drops in the pump suction also rises with rise in flow rate, making low pressure and cavitation at pump suction more likely to occur. So the fluid PV is equal to constant. So if the fluid velocity increases, the pressure at the suction will decrease automatically. So this can also have a cavitation in the pump suction. Reduction of the flow at the pump suction. So certain minimum flow is required by the centrifugal pump to keep them from running dry, as indicated by the pump performance curve. If the liquid flows below this limit, possibility of developing vapor in the pump and cavitation increases. So if the flow is reduced, this is same case as in the pump loses suction. That means pump loses the suction, so there will be reduction of the flow to the pump. So as the flow to the pump is reduced, then the vapor pressure of that liquid will be less than the surrounding pump pressure. So the liquid will collapse. Undesirable flow condition caused by the obstruction of or sharp elbow in the pump suction piping. So this all obstruction, sharp elbow in the suction piping can increase the frictional losses. So I have told you that NPSH will be decreased because HA plus P plus HA, PA plus, so NPSH formula we know is PA plus H minus HS plus frictional losses plus vapor losses. So I have discussed you that if the temperature increases, vapor losses will increase, and if there is an obstruction in the suction piping, then the frictional losses will increase and it will reduce the NPSH. So the NPSH is reduced, so the pump will lose suction. If some amount of liquid also flows in the pump, then its pressure will be very less than the surrounding pump pressure, and the liquid flowing into the pump, it will make bubble and will collapse. The pump is not selected correctly. If the available might fall below the required limit, cause cavitation. So the manufacturer gives a required limit of a NPSH required to a pump, and if you are not maintaining that, if you are installing the tank below the pump and making the NPSH available very less than the required, then it will cause cavitation. So thank you guys. Hope you all understood about what is cavitation, its effect, what are the causes. So if you like the video, please like and subscribe, and if you haven't subscribed till now, please subscribe the channel to get more videos like this. Thank you guys. God bless you.